And thank you for being here in this room when it's really nice and warm and sunshine outside. Today I'll talk about an adaptation to climate change. Now this is obviously a huge topic and it just includes a variety of disciplines. And so what I'll do is a very kind of a less ambitious approach is to really look at the economics aspect of it. I'm an economist, but I direct a interdisciplinary program at MSU, which is the kind of campus-wide program to get researchers as well as students from different disciplines together. In my own research, I've worked with climatologists, agronomists, soil scientists, you name it, many other disciplines. And in the process, I sort of learned the importance of other disciplines as well as actually the importance of economics. So it's a kind of a reinforcing of the kind of role that economics can play when we work across disciplines. So today's talk is really about the economic side of adaptation. And in particular, I'll talk about two components of that. One is, now we are facing this grand challenge of adaptation to climate change. And now let me turn around and go into the long history of economics research and ask the following question. Okay, so what can I learn from what we have done over the past long time, century in economics? And what are the relevant lessons when we think about adaptation? So that's the first part of the talk. And the second part is, now armed with what we've learned in economics research. And now let's look at the new aspects of adaptation. Okay, so and then the question is, are those lessons that we learned enough? Do we need new approaches? Or do we need new elements in the economics modeling, okay, to handle or to tackle adaptation? So over there, I'm going to be talking about I'll be making two arguments. One is there's a nice framework in terms of decision making in economics that could actually be extended to study adaptation. And the second argument I'll make, I hope I have time to make that, is now for adaptation, we really need a kind of interdisciplinary approach. And I'll show you by example how by including knowledge from other disciplines, we can really make the economics model not only more meaningful, but also more useful. Okay, so those are the sort of two goals I'll talk about. And I know the audience is interdisciplinary, so just stop me if you have questions about economics jargons. But I assure you that I do not have math equations. It's not a much economics model. So this is the brief outline. So first I'll talk about the lessons from the past economics research, and then talk about the conceptual framework as well as the interdisciplinary approach. Now, I'm drawing this talk from a bunch of research that I've done over the years with numerous co-authors. And I just briefly listed those. Most of the papers are published, and some papers are still working papers. Okay. Now, for this audience, I don't think I need to motivate why we need to think about adaptation. But just let me say one thing is in terms of the international efforts in forming international agreements to curb greenhouse gas emissions, we are far from being where we should be. After the collapse of Copenhagen in the recent, think about the recent Doha round, where the Conference of Parties were negotiating what to do. So basically now what we have is Kyoto Protocol is expiring, and that is going to be replaced by a baby version of that until 2020. And then we promise, we sort of make a commitment that we will start to negotiate a treaty. Okay, we are going to actually have a treaty in place by 2015 that will kick in by 2020. Now, We do not know the form. We do not know of that treaty. We do not know the level of commitment. Is that going to be like a baby Kyoto, or is it going to be much more ambitious than Kyoto? Okay, there's lots of uncertainties. But for one thing, it seems that it's unlikely that we'll be able to do the 450. Okay, so 550 maybe. We don't know. So it's rather bleak. Okay, and this really sort of argues for the importance of adaptation. And we see that. We see the numerous government programs in terms of the grant agencies, in terms of the money that has flown into adaptation research, as well as in terms of the activities. The local, from all sorts levels of the society, from local communities to state governments in the U.S. or provincial governments and to national governments. So now increasingly we are talking about adaptation. Now, the economics of adaptation. Before I go into the economics, let me be clear as for what I'm talking about, or what I mean by adaptation. There is quite a variety of definitions of adaptation. So in this talk, I really define adaptation in terms of the kind of from the economics approach is a kind of major change in decisions and in resource allocation, either in response to past events, past changes, or in anticipation of the following changes, that is large-scale and long-lasting changes. Okay, so if you see it is raining outside, you bring an umbrella, that is not the kind of adaptation I'm talking about. Okay, I'm really talking about long-lasting major changes and the kind of responses to those changes in terms of decisions and in terms of resource allocation. Now, why economics? So to a lot of, so in my experience, maybe not for this audience, to many non-economists, many times when they think about economics, they think this is really useful for cost-benefit analysis, right? For sometimes policy evaluations, for even sometimes for accounting, to think about the different elements in the costs and benefits. But to economists, economics is really about incentives. This is a critical element. Economics is about incentives. It's about how individuals make decisions, how they respond to external changes, okay, to external factors, and it's really what is driving their decision. Okay, there's a paradigm or different paradigms in economics, but at the end of the day, it's about incentives. Okay, so this theme will come back all the time when we think about the historical the economics research conducted previously. Okay, so now when I go back to the huge economics literature and think about where I should go to get useful information about adaptation, there are at least 3 areas that I can go to. Okay. One is there is actually a small literature in economics that studies adaptation, including adaptation to historical environmental changes, major changes. For example, there's some papers on the adaptation after the American Dust Bowl. Okay. So, but the literature is very small, and the kind of historical events that happened are very different from climate change. So I will not really go into that literature for the lessons. Okay. And the second branch of literature is what has been going on recently, and that has attracted a lot of attention. That is the impact assessments. So there is quite a rapidly growing literature on impact assessment, economic impacts of climate change. Okay, so for example, the hedonic models, when they think about, is U.S. agriculture going to be affected positively or negatively by climate change? There's a bunch of papers, lots of arguments, and so I go through that literature, but the way I approach that literature is more critical, because I argue, this is my last argument, I argue that that literature is not going to be directly useful for studying adaptation strategies. They include adaptation, but it's not very useful when we think about concrete adaptation strategies. Okay, to do that, you have to go beyond that. We have to go to interdisciplinary approaches. Okay, now the last one is where I really want to go to, and that is the adoption literature. Okay, so the adoption literature of new technologies and practices, there's a huge literature, and that is where I'm going to be going to draw on lessons for adaptation. Now, why adoption? There's actually a very nice linkage. There is a similarity, a shared feature between adoption and adaptation. And that is, they involve discrete changes. Now, if you look at economics, we do a lot of, when we do policy analysis, we say that, okay, suppose there's a policy intervention. Okay, there's a tax policy change. Is that going to be good or bad? So the way we approach that problem many times is what we do, the comparative analysis. That is, we have a system, we have a equilibrium, there's exogenous change, such as a policy change, that affects the system. We look at what happens in the system. We look at income, we look at decisions, income, prices, things like that. Okay? Now, most of the time, the way we do that is through the differential calculus. That is, to look at small exogenous changes and look at local responses. Now, because that's predominantly the economics way of evaluating many kinds of policy changes. Now, we look at the local effects. But for technology adoption, it's different. Technology adoption is always discrete. Okay? There's a new technology. It becomes available. And then I think about whether or not I will adopt. If I adopt, there's actually a discrete change in my payoff and in my decisions. Okay? So this is very much like adaptation. The way we define adaptation is not like, again, an umbrella in response to rain. It's really major changes. Okay? So this feature of being discrete responses to discrete changes, okay, is shared by adoption and adaptation, and that's where I'm going to go. And it turns out that this is also very useful in the sense that there's a long history. There's a long history of adoption research, driven partly by the Green Revolution. Okay, so I'm not going to go into the literature, specific literature, but basically, if you look at the adoption literature, it's very interesting. So before economists started to really be serious about adoption research, it's the sociologists who are doing it. So sociologists, the way they approached the problem was very social, right? Sociology is a group of people, they are leaders, they are followers, you become aware of the technology, you become interested, you evaluate it, and then you adopt. Okay, so it's very much like very intuitive, right? And then economists started just to ask the question, why? Why would I be interested in the technology? At the end of the day, what is driving my adoption decision? And this is really the kind of economics thinking, and that's the introduction of the threshold model of economics. Okay, so the threshold model basically argues that if there's a new technology, okay, then I will adopt if and only if the benefit of adoption, okay, first of all, is higher than the cost, and secondly, many times it has to pass the threshold. Okay, so you can tell this is really going from the social, the society group of decision makers into an individual decision. Okay, so economics is very much about individual incentives. Okay, so now we go into the individual, go into not necessarily the brain, but think about the decision-making process, and then we ask the question, okay, where's the threshold? Why is this individual adopting the technology? Now later on, of course, economics came back to the community. Okay, so now so in the literature we do look at information transmission among the group of people. Okay, from the early adopters to later adopters. We do think about the network externality. So sometimes if one individual adopts, if you have many individuals adopt, maybe there's a marketing service that's going to come over. Okay, so maybe that's going to reduce the cost of everybody. Okay, so the kind of network externalities, and then we look at the diffusion patterns. But at the core of the economics model of adoption is individuals, is individual incentives. Okay, now what are the lessons? Okay, so I'll have 4 slides on the lessons, so I'll go over those relatively quickly. So the first one is, the lesson is, when we think about, the first lesson is when we think about the diffusion patterns. Okay, so sociologists and others tend to look at, the logistic diffusion pattern, right? The technology gradually gets adopted and those kind of things. And when we think about that, it's actually very strong evidence that it's the individual incentives, the individual decisions that drives the diffusion. Now, it's basically here in the economics model, the key feature here is individual heterogeneity. individuals are different. Their thresholds, their adoption thresholds are different. Okay, now, so how are they different? Okay, so this is the second point. They can be different in their net benefits, in their information learning. So let me give you an example. Okay, distance to markets. This has been proven to be a major factor in driving adoption of many technologies, because if you are closer to a market, you adopt a new technology that increases your yield. Okay, that is the benefit you get will be higher than those people who are further away from the market. Okay, so and in agriculture, farm size has proven to be a major factor. Bigger farms tend to adopt for major technologies. Bigger farms tend to adopt early. Smaller farms not. Okay, so it's very intuitive, right? But the key thing here is the individual heterogeneity that drives the diffusion pattern. Okay, and so this is actually also important because when we think about adaptation, okay, this would be a key factor when we think about adaptation. Is individuals will be different. They will be making different decisions, even though we make recommendations. It's a blank level, the blanket level on recommendations. So. Now, the second thing is about the other part of the lesson is in terms of information and learning. Many times, formal information informal information, okay, is as important as formal information. By formal information, this is the information about the new technologies. Okay, formal information can come from a variety of sources. You may have extension agents, university extension agents, going to the farmers or the marketing firms or the manufacturers or consultants, going to the individual decision makers and release information about the new technology. Informal information is typically from the kind of a word of mouth communication. Okay, your neighbor adopted, okay, and you were chatting with your neighbor. Okay, so it turns out that empirically you can find that many times the informal information can be as important as formal information. Okay, and this is actually very important in developing countries because in developing countries, formal information is typically lacking. Okay, now, however, here is one thing that is a trick. Increasing this kind of informal information transmission, that is increasing communication between adopters and non-adopters, may not always help. Okay, and the reason is the aspect of strategic delay. Okay, think about the following. Suppose I'm in a village, it's a group of people, there's a new technology that is expensive, there's uncertainty as to whether it's going to work. What do you do? And also you can learn from other adopters. So what do you do? Well, you expect or you hope your neighbors will adopt first. Okay, they adopt. If it is successful, you adopt. If it is not, they incur the sunk cost. Okay, so in this case, so basically the lesson here is that when at the early stage of the diffusion process, expecting this kind of learning from early adopters may actually slow down the adoption process. Okay, but of course, in the later stages of the diffusion process, things get reversed, right? You already have many adopters, and if you can learn from them very rapidly, and then basically you can improve the diffusion process. Okay. Now another lesson is uncertainties play a big role in adoption. Okay. And there is a variety of ways to reduce uncertainty. Okay, say from a marketing demonstration. Okay, you can have demonstration. We see sometimes in stores the demonstration of a new utensil, for example, right? Okay, so this is the kind of things that the literature has really sort of shown that it really works. Money back guarantees. This is a case where you buy a new technology, a new equipment, it may not fit. Okay, so you can go back and return it. Warranties, that's for quality. Post-sale support. Brands actually is very important for credence goods. That's for the goods that you do not. And it's not like you can research whether the good quality is really the quality is really good. So sometimes you experience it. Sometimes for credence good you cannot even after you bought it, you used it, you do not know its quality. Okay, but anyway, so this kind of there's a set of a mechanism already being practiced that can promote adoption, and those mechanisms should be the kind of things we should think about when we think about adaptation, promoting adaptation strategies. Okay, and also risk-sharing arrangements. Okay, cost shares, credits, insurance. So we actually talk about this quite often when we discuss adoption of energy efficiency technologies. Okay, so cost share. There's lots of a subsidy in terms of the cost share. Okay. Now, the next lesson is increasing returns to scale. There are certain technologies. Okay, they have the following feature. Okay, in producing, in supplying the technology, there's a high setup cost, but once the system is set up, the variable cost, or that is I increase 1 unit, how much more additional, what's the additional cost in producing 1 more unit? The variable cost is low. Okay, for example, biotech, many software. Okay, software, I mean, the big setup cost is what? Is your intellectual working it out. Once the software is written, it's basically there's no cost of producing more. Okay, so for this type of technologies, okay, there's a strong sense of path dependence. Okay, in the sense that typically these technologies, because of the low variable cost, when a firm actually gets this technology, it's very easy to occupy the market. Okay, the entire market. So what happens is you're going to have monopoly or several big firms oligopoly. Okay. Now in this case, once this technology is established, it's very hard for other technology, even if that technology is better, to come in. Okay. So just the classical example is the QWERTY versus the Dvorak keyboard, the QWERTY keyboard, right? Okay. So but anyway, so this is actually when we think about adaptation strategies or new technologies for adaptation, this is actually something that we should think about. Is whether or in cases where there's increasing returns to scale, maybe the government or other agencies should come in early, okay, before the technology is established. Okay. Now the next lesson is many new technologies are actually embedded in capital goods. Okay. So this is actually very, there are lots of examples. For example, in the precision agriculture, many times the precision agricultural technologies are embedded in the big machines, in the combines. Okay, or the energy saving technologies. Now we have a new technology that is more efficient stove or more efficient refrigerator. Okay, in order to get the new technology, you have to buy a new refrigerator. Okay, so in this case, the adoption actually is through getting a new entrant, basically, getting a new unit. Okay, so what's the lesson here for this kind of technologies? One thing is what actually has been very effective is learning by renting. Okay, think about a farmer who has to buy a big piece of equipment in order to use the new technology. Okay, so there's lots of a sunk cost, and there could be a credit constraint. So in this case, renting turns out to be more effective, because renting, your capital commitment is limited, and you can still use the new technology. You can actually learn. Okay, you learn about the new technology before making the commitment to buy it. Okay, another thing is actually sometimes, okay, for this kind of technologies, sometimes government policy, government subsidies to promote adoption of these technologies actually may not be very effective. Okay, think about you have a subsidy for a new technology, but then in order to use the new technology, you have to buy a big piece of equipment. Okay, so basically, when you have this kind of a subsidy, only the new equipments, only the purchasers of the new equipments are basically responding to this government incentive. So the degree of response, okay, or sometimes you measure how effective the government policy is. Sometimes it's limited because of this feature. Okay, and this is actually everywhere, especially for energy efficient technologies. Okay. Now, the next lesson is institutions. Institutions can play critical roles, okay, in affecting adoption, in affecting the adoption incentives. Okay, an often talked about example is the lack of incentive for rent. Think about a rental property. Okay, I'm renting a house. I'm renting an apartment. Okay, and the institution is such that I'm paying my own utility bills. Okay, but who supplies the refrigerator, who buys the stove for the apartment is the landlord. Okay, so if there is a more energy efficient refrigerator, okay, it's the renter benefits, because now the renter's utility bill goes down. Okay, but the landlord may not be able to capture all of that. Okay, so the landlord basically, if you think of, compare this situation with the case where the renter owns the apartment, okay, owns everything. Okay, in this case, the renter may be waiting, the individual may be waiting to buy a more energy efficient refrigerator, but when the rental, when in a rental arrangement, the landlord may not be able to do it, may not have the incentive to do it. Okay, and this also happens in the short term of sharecropping versus terracing, for example. Okay, terracing is basically you do the land, you go to different levels that helps with the soil erosion, but this is a long-term project. Okay, and if I have this sharecropping, if I'm a sharecropper and have this contract for 2 years, then I wouldn't have incentive to put in a terracing at all. Okay, so institutions matter a lot, but the problem is many times the institutional innovations do not always happen. When we see that an institution is not working, it does not automatically mean a better institution will actually be adopted. Okay, so many times actually institutional innovations happen only only when there's a crisis. See, for example, in California, when there was this is a couple of decades ago, when there was a severe drought in the 1990s, that's when the government really saw the problem and started to introduce water markets. Okay, now the last lesson that is from the literature is more like the economics methodology. It's recently, we can actually now, economics is becoming more and more experimental. Okay, so we can run many experiments. Sometimes we run lab experiments with students and other people, or sometimes we do field experiments. So for the kind of hypothesis that from our theory, the kind of hypothesis we make, now it's actually possible to test at least some aspects of the hypothesis in labs. Okay, that's one thing. And the second thing is economics now is sort of like there's a new branch, is a new subfield of behavior economics that really goes beyond the neoclassical economics paradigm. And I'll stop here, but it's basically the contribution here is the models, the economics models can be made to capture the reality better. Okay, so those are the lessons that from the adoption literature. Now, I move on to the second part. Okay, now, so I go to the economics literature, and I know there's a bunch of lessons I've learned that are relevant for adaptation. And now let me think about what are the new things in adaptation. Okay, what are the new things that in the past the lessons just cannot address? And now I have to think, about the framework, okay, the conceptual framework for economics research. Now, one thing is the climate change is just so the impacts will be really big, and the geographical scales are unthinkable. Okay, so the kind of lessons we've learned from the past adoption research many times just cannot be carried over, because now we are talking about out of sample. Okay, if you're thinking about empirical research as for how individuals respond to external changes, you have a bunch of data, historical data, and you just cannot directly do a projection to make forecasts about the future, because now we are talking about the changes that are just never happened before. Okay, so that's a kind of a general challenge, is now we have to think about out of data, out of sample predictions. Now that's one thing, and the second thing, this is not unique. This is not unique for adoption. Okay, there are many aspects of the other kind of adaptation strategies. We face the same thing. For example, insurance. Insurance has been considered as one of the really successful or much needed risk management strategies. But now, when you think about the climate change, the traditional insurance is not going to work. Because insurance needs a probability assessment. You need to be able to calculate the probabilities of the different possibilities. Now in climate change, we don't have that probability measure. Okay, so we are really in the world of either Bayesian uncertainty or ambiguity. How do you design insurance contracts to handle those situations? Okay, you can have weather derivatives, or you can have a kind of insurance plus a kind of a trading of securities. But this is something new. Okay, it's not something. It's not like you go to the literature and you can really find answers. Okay, migration, that's another one. Okay, so migration. I mean, in labor economics, you must have tens of thousands of economists in the world who study migration. Okay, pull models, push models, and those kind of things. But now we are thinking about the possibility of mass migration when the international mechanism or the constitutions or the institutions, the international institutions governing migration is in no way capable of handling environmentally driven migration. Okay, Sweden is maybe the only one or one of the very few countries in the world that actually recognize environmentally driven migration. Now you go to other parts, there's war, there's refugees, okay, driven by typically the institution in migration is always the receptive country, right? It's the country where people migrate in. They have the laws and the rules, right? And typically, there's economics driven, there is war driven, and all sorts of things. But think about environmentally driven migration. Okay? The kind of institutions we have are just totally lacking to handle this. Okay, so this is not only adoption; it's really for many aspects. Okay, now so the economics framework. So I'll briefly talk about two things. One is a conceptual framework. The other is an empirical strategy. Okay, the empirical strategy is where I show the interdisciplinary approach actually helps, and the conceptual framework is what I call this extended real options framework. Now, if I ask myself, okay, I'm thinking about a conceptual framework in economics to deal with adaptation. Okay, what are the features of the framework that I think it should have? What are the desirable features? So I have a list of the desirable features. Okay, so it should be able to capture uncertainties for sure. There's lots of uncertainty in adaptation. And the second is irreversibilities or adjustment costs. That is, many times the kind of adaptation measure we're talking about is irreversible or it's very costly to reverse. Think about flooding. Okay, you're building a dam or dikes for flooding. Okay, it's very expensive to build, and it is also expensive to get rid of. Another feature is many times the benefits accrue in the future when the costs are incurred now. Okay, this is again the dams and dikes like that. And also there's going to be learning. Okay, even though we might have a long historical data where we've learned a lot about certain things, but now we're in a new regime. Okay, under the climate change, we're in a new regime. The kind of historical data, the trend, basically there might be a structural change in the trend. Okay, so there's going to be lots of learning. Okay, either your decision will be anticipatory, that is anticipating learning, you make decisions, or in many cases it's reactive, as you don't know and just happened and you reacted to it. Okay, and the next one is the distinction between gradual changes and extreme events. Okay, and in economics there has been arguments about the tails, that's the extreme events, fat tails, and how that drives the impacts of climate change. The same thing is important for adaptation. Okay, so think about responding to extreme events, right? You have to build up a response mechanism to earthquakes or to major hazards, and maybe forest fire and those kind of things. Many times you are not using it. Okay, versus gradual changes. Okay, you see that every day, you gradually build up your response mechanism. Okay, so the conceptual framework needs to be able to handle or distinguish between those two things. Okay, and the last one is actually very important. Adaptation may take time. Okay, so if you have an external factor that is changing rapidly, and it always, your response always lags, So basically what happens is that before your response kicks in, there's a period when there's going to be lots of losses. Okay, economics losses, loss in human life. So the kind of typical economics approach of comparing two equilibrium. Okay, what happens before adaptation? What happens after adaptation? You look at the equilibrium. After all of the processes have settled down, that's not going to give you accurate measures, because actually the process, you're going to be suffering lots of losses in the process. Okay, so the framework needs to take into consideration of the process of adaptation. Okay, and here's my proposal. Okay, so before I go into the proposal, let me just briefly, maybe a couple of minutes, to give you a very simple story. Okay, and that's really the intuition for the entire proposal. Okay, so I believe a lot of you, or most of you, are familiar with the cost-benefit framework in economics. Okay, there's an investment project. Okay, should we go ahead or not? Cost, benefit. If benefit is higher than the cost, let's go ahead. Okay, so here's here's the example. Think about an adaptation project. Okay, so basically the investment that is needed is 84. Forget about the units, just the number, 84. Okay, and currently the benefit. Okay, so this is a typical case of investing now with the benefit accruing over all of the periods. Okay, currently the benefit is 10. Okay, but next year in the future, I'm not sure whether it's 15 or 5. Okay, there's a study as for whether this adaptation measure is going to be effective or not. Next year, I'll know. The results of the study will be given. Okay, will be released. So there's a 50-50 chance that this adaptation measure really works. In this case, I get $15 or kroner or whatever each year, versus if it is not successful, is 5. Okay, so in expectation is 10 every year. Okay, suppose I have a 10% discount rate. Okay, and I'm risk neutral. So now let's do the standard benefit cost analysis. Okay, so I do this. What's the expected net present value? Every year I get 10. I have a 10% discount rate. I discount it back. It's basically you do the 1 over 1 plus r, those kind of things, and then basically your net present value is 100. It's 10 over 10%. It's 100. What is my cost? My cost is 84. Okay, so I have a net benefit of 16. So I should go ahead and invest now. Okay, so this is the classical cost-benefit analysis. But now, let me ask you the following question. Okay, so this is the setup. What if? What if I don't do it now? What if I wait until next year? Suppose I can do that. Suppose I can wait until next year to do it. Well, next year, what happens? So remember, by next year, I will have the information. I will know whether this adaptation measure will work or not. Okay, so there are only two possibilities, right? If it is not favorable, if it does not work, okay, I only get 5 each year, then my calculation would be, okay, every year I get 5, okay? So this 10% discount rate, discount back, I get 50 as the net benefit. That is lower than my investment of 84, so I'm not going to invest. I'm not going to do the adaptation. Okay, now, what if it is favorable? It's 15, of course, 15, okay, divided by 10%, 150, so I get 66, okay, as my benefit. I will invest. So next year, there are two possibilities. Either I get 0 or I get 66. Each happening with equal probability. So what is the expected value? The expected value is 66 times 0.5, 50%, plus the 0 part, so that's 33. But this 33 is accrued only next year. So I discount it back, 1.1, right? Discount 10% discount rate, I get 30. So that is, if I delay, if I do not make the decision now, but delay until next year to make the decision, my net benefit is 30, versus before my net benefit, if I just invest now, my net benefit is 16. Okay, so the answer here is, I should not invest now, even though my expected net present value is positive. It's 16, it's greater than 0. What is going on? What is going on is that by waiting, I actually get more information. By waiting until next year, I'm making a more informed decision. My decision will be based upon the new information, and that information helps me avoid this bad investment of investing 84 in return for 5. Okay, that's basically the essence. The essence here, the framework basically says when there's an opportunity to learn, When there's irreversibility, that is, I invested, I cannot really just come back, there is actually benefit in delaying that. And that basically can handle a lot of the processes, basically the entire list of the features that I talked about in that page. Let me give you a couple of examples. Okay, just a couple of examples. One thing is, in this framework, it's actually very likely that before you adapt, you suffer losses. Okay? So even though you are suffering losses, you are not adapting. The reason is you want to learn more about it. Okay? So it's actually it could be a common feature that you suffer the process loss is there. Okay, before you make the major decision of adaptation. Okay, this actually becomes very important because if you can design an adaptation mechanism that can reduce the degree of irreversibility or reduce the degree of sunk costs, okay, that can shorten the waiting period. Okay, that can shorten the waiting period so that now individuals are more readily adapt and more readily to make the decision to adapt. Okay, so this is like the second point, the sequence. Sometimes if you can break things up, a sequence of small steps versus one big step. Okay, this is like instead of building one huge dam, you build a sequence of small dams. Okay. Now the second thing, a lesson we've learned is I've done quite some research on what we call the commitment cost. That is the reluctance. So let me give you an example. So in the U.S. and also in other parts of the world, there have been many water markets. Okay. Now one big complaint about the water markets is that the water market is there, but the volume of trading has been small. Okay. So what happens is, like in the Western U.S., initially how the water market was set up is that farmers have to sell their water rights. Their water rights is basically you have this piece of land, you are entitled to a certain amount of water every year, forever. If you sell your water rights, basically you have no water forever. Okay? So you see that because of the uncertainty involved, because of the transaction costs, if I sell the water rights, I cannot get it back. Okay, many farmers are very reluctant to sell. Okay? So however, if you change this, instead of setting up the mechanism where the farmers sell their entire water rights, they can lease that water rights out. Okay? This basically removes the irreversibility. I lease it out this year, next year, but I can get it back. And that definitely increases the trading volume. Okay? So gradual changes in extreme events. A major feature of extreme events is you have to have redundancy. Okay? So think about extreme heat wave. How do you respond to extremes, like a big heat wave? Well, you have to have the redundancy, spare kind of a capacity to generate electricity to cool down, okay, for air conditioning. Okay. Well, redundancy basically means what? It means that it's a sunk investment. It's an investment that is not used all the time. Okay. So the way we respond to extreme events will be different because of the sunk costs. Okay, versus gradual changes. Just one example of policy intervention. So this is an example that we did for land use decision. Okay, forget about the specific decision where the data comes from. But here the decision is I have one land use. Okay, I'm trying to make this change into another land use pattern, grow a different crop, and the government wants that. It's basically a more environmentally friendly crop. Okay, so the government has different mechanisms different ways to subsidize the farmer to do that. So we basically studied several ways where the government can subsidize the farmer. We have the insurance policy, we have a fixed subsidy, we have a cost sharing subsidy. Cost sharing, we do this, we cost share, or we have a tax break. Okay, so we anchored the different policies so that they gave you the same kind of costs. And here's what happens: the horizontal axis is the year, vertical axis is the likelihood of the farmer converting to this new crop, more environmentally friendly crop. Well, this is what happens. I mean, clearly the insurance policy is more effective, and tax break just doesn't work. Initially it works, and then gradually it just peters out. Okay, so I'm not going to go into the details as for, there's actually, it's quite intuitive to explain this once you understand the mechanism. I suppose mostly has to do with the variance. A tax break is going to make the payoff more uncertain. Okay, and versus insurance shrinks the variance. Okay, now in a static framework, in a typical economics framework, the policies will have the same impacts. But in this kind of framework I was talking about, the impacts are totally different. Okay, so maybe 2 minutes. Okay, just 2 minutes. So I'm not going to go into the details to talk about the interdisciplinary approach. Okay, because this is where I think it's really a lesson for economists and also a lesson for non-economists as for how economics can contribute to this. So basically, what we are trying to do is to predict. Okay, think about climate change. Okay, suppose there's an area. Okay, climate will change, and okay, traditionally the adaptation is what? The historical studies, the kind of impact assessment I was talking about, they basically assume that the existing crops are given. Okay, so your adaptation strategy will be developed out of the current mix of crops, corn, soybean, maybe some other crops. So what we are doing is, what if there's a new crop? Okay, maybe it's entirely new crop. So in this case, we are talking about an energy crop, switchgrass. Okay, how do you predict the adoption of new crop when the new crop is not in your data? Okay, it's not in your data, right? If historically you have the data, this crop is in the data set, you can do it. But in this case, it's an entirely new crop. It's not in the data. So what do? So we basically defined each crop by its physiological attributes. Water, heat tolerance, number of growing days needed, okay, pH tolerance, those kind of the water need, water use efficiency, radiation use efficiency, all of those, okay. So, and then what we did is we matched the crop attributes with the local weather and soil characteristics, okay, water use efficiency, water supply, okay. The radiation use efficiency, sunshine. Okay, the pH level tolerance, the pH level of soils. Okay, so we basically went to soil scientists, we went to climatologists, hydrological science, and crop scientists. Okay, and we developed this model that enabled us to match all of these features. And then the result is, as long as the new crops, all of the physiological attributes are spanned by all of the other crops available in my data, okay, their attributes span this new crop. By span, I mean basically, okay, there's one feature of this new crop, okay, there's another crop that can actually capture this. Okay, there's another feature, it's a different crop, has a feature that can capture this. Okay, so, and that is actually doable in this case. Okay, then we were able to basically generate very nice predictions about the adoption of the new crop. Okay, just to conclude, okay, there's a bunch of really useful lessons, but there are some new approaches that are needed in economics research, and so they are. I have several other future directions I talked about, more decision frameworks, especially based on behavior economics. In the kind of interdisciplinary approaches, this is something we are doing, is link the models. Okay, we have the economics models and other models, process models. We link them. We do the coupled human nature systems. And one thing I did not talk about is institutional innovations. Okay, how do we think about institutional innovation? Okay, and with that, thank you very much.